Hello everybody, how's everybody doing? I hope you're doing just fine. Today I was going to talk about the existence of time, but I have to apologize. I'm going to be postponing that till Wednesday. Instead, some other issues came up which I thought I couldn't let go by. So I'm going to talk about a couple things I've been talking about, which is infinity, what a straight line is, and especially couple comments made about black holes, which show really that people have a gross misconception of what a black hole is. And I mentioned that, I think it was last time or the time before, that when I was on JFG's program, JF Garepi, and he also made the same error. He thought a black hole was some kind of ball, some black ball, small black ball, maybe a tiny little itsy-bitsy ball. I want to make sure we clarify today that a black hole is zero-dimensional, has no size, no diameter, no volume. Okay? It's nothing. So that's what I want to get to today. I want to make sure that's clear. Okay, so that we don't fool around with this black ball deal. A black hole is not a black ball. It's a hole. Otherwise, they would have called it a black ball. Anyways, let's begin with the first question or the first issue that was brought up. And here it is. Okay. And the fellow says, lines of electric force extend to infinity. They cannot abruptly end in space. You cannot measure infinity. But you can rationalize upon and perceive it. I don't know how you can. The lines of force between the plates of a condenser can make this self-evident. Okay, that's what the fellow put in there. How do we answer that? Well, first of all, here we have side by side so we can follow along. Okay. I would ask the fellow if he's ever been to infinity. I mean, where is infinity? What is infinity? And instead, it'd be nice if he could rationalize it for us. And a good place to start is by defining infinity, absolutely, perfectly, unambiguously, rigorously. That's what he's got to do. He's got to define what the word infinity means. And then the other issue is says lines between plates. Well, if anything is between two things, for sure it's not infinite, okay? And even Aristotle told us that. And here you see a picture of that, of lines of force between two plates on a condenser. And, the lines of force begin there and end there. So there's no infinity about it. And you'll find other similar pictures on the internet. So, this guy's got to clarify what he means by infinite if it's going to be between anything, between two objects. So no, lines of force are not infinite, meaning, and he says they cannot end in space. And there we agree, because space is not a physical object. That's why it cannot end in space. They end in another atom. They don't go to infinity. The fact that you didn't trace it to where it ends doesn't mean that it goes to infinity. It means it goes to another atom, because it's the lines of force are threads of the rope. And that's why they don't go to infinity. They stop at the next atom down the road, or one farther down. Okay, here's another issue that was brought up. And this one was kind of funny also. Straight line on a sphere. A straight line on a sphere. Yeah, you heard it right. Referred to as a geodesic, appears curved, but it is actually straight. These people swallow all kinds of word wizardry from the mathematicians. You can tell them anything and they'll just repeat it. They don't even know what they're saying. I want you to take a straight ruler. Okay, or as straight as you possibly can get one, right? I mean, obviously it's got some imperfections. And I want you to lay it anywhere you want. You got a choice. You can lay it anywhere you want on a basketball. Okay, that's pretty round also. And I want you to see if it matches the curved surface of the basketball anywhere. Okay, and I don't think you can do that. And so what they did, they converted the so-called line. Remember what a line is. According to Aristotle, you know, they don't talk about geometric lines. What they talk about is itineraries. And so they said, well, you know, I always went forward, so I went straight. But they went on a curve and they call it straight. And because they're talking about motion, they're talking about the shortest distance, meaning shortest distance traveled along the surface. They call that a geodesic, and they say that it's straight. No, it's not straight, because straight is an adjective. You can only apply it to objects. An itinerary along the surface of a ball is not a physical object. It's a verb, and so you can only qualify it with adverbs. You can't say straight trajectory, not in physics. Maybe in ordinary speech and mathematics and all those religions, you can say whatever you want. But in physics, you cannot say straight trajectory, straight itinerary, straight orbit, or whatever, straight motion. No such thing. It's rectilinear. That's the correct word, because you are moving rectilinearly, meaning that it's an adverb. Okay, you're qualifying motion in or curvilinear. You can say curvilinearly as well, that you're moving in a curve. Okay, so the geodesic is not a straight line. Only in mathematics do they call it straight line. And here you have a little article from the Wikipedia. And it's got to do with this, what is known as the Great Circle. It says the Great Circle distance is the shortest distance between 2 points. Again, they're talking about not distance, but distance traveled. They're talking about motion along the surface of a sphere, okay? Between 2 points on the surface of a sphere, measured along the surface of the sphere, as opposed to a straight line through the sphere's interior. Okay, because then, yes, you can go in a straight line if you can go through the sphere's interior, right? The distance between 2 points in a Euclidean space is the length of a straight line between them. But on the sphere, there are no straight lines. So what is this fellow talking about, a straight line on a sphere? In spaces with curvature, straight lines are replaced by geodesics. Okay, so what they do is, again, you know, they're doing word wizardry. They're saying, look, we're going to call it a geodesic, and we're going to say it's a straight geodesic, meaning straight line motion along the curve. What is it? What is that? What nonsense is that? That's just word wizardry. That's all it is. If you define the word straight and the word curved rigorously, then you won't have a problem. But of course, if you use these words any way you want, and you go back and forth, and you say, well, under the fourth dimension it's a straight line, and nonsense like that, well, yeah, then you know, you can run around forever, because no one can object to what you're saying, because no one understands your language, because you're moving the goalposts, you're changing everything as we go along. Okay, so no, keep that in mind. A lot of that is word wizardry and nothing but. Okay, and here we had a fellow talk about black holes, and that's the issue I want to get to today. Bill gets hung up about singularity being zero-dimensional, but think of it as a representative point which will account for the gravitational strength of the collapsed star, much like the point in the middle of Earth representing its gravitational pull. Well, we're not talking about a point, like a dot, two-dimensional dot. No, we're talking about the center of mass, or the center of a location. That's what it is. It's a location where you can maybe draw lines to it or whatever, okay, distance, equidistance center type of thing. So a center is not a dot, is not a point. But when you use the word point, again, it's word wizardry, because you can use the word point as a location or as a dot. And so they're talking about singularity. What is a singularity? You know, and if you call it a point, what do you mean by point? Are you saying it's a physical object, is a geometric figure? Is that what you're referring to? Or are you just saying that a point is a location? You know, these things need to be clarified. And so here's my reply to that, okay, side by side again. You know, as the point 0D. In fact, according to Euclid, it is 0D. In fact, the mathematicians today continue to say that it's 0D. But what do they mean by 0D? They don't mean that it's got length, width, and height. It has nothing to do with that. They say that you don't need any coordinates, as they call it, meaning number lines, to locate it on a Cartesian coordinate system. That's what they mean. So it's all twisted around, okay? We're not talking physics, we're talking mathematics. That's what we're talking there when we say point, okay? So the point is very misleading because you really got to know what you're talking about. Are you talking about physics? Are you talking about a dot? Are you talking about a little ball? Which is what this is going to lead to, okay? We're talking about a black hole, and they're going to call it a point, a singularity, and that's very misleading because that word singularity, like the word point, you know, it can mean two things. It can mean a little ball, and it can mean a little hole that's got no volume, no diameter, no radius, no size, no anything. There's nothing there. And then gravitational strength is the concept. Okay, so you cannot say that you're going to do something with a gravitational strength. Okay, there's no such physical standalone object. So you can't use that to depict the singularity or vice versa. Use a point, a dot, to represent the gravitational strength. Okay, because that's like putting a heart to represent love. Then you got the center of mass point, again, is not a thing. Okay, not an object, it's not a body. And so is a point a dot or a location? That's what the person has to answer. You know, are you talking physics or are you talking mathematics? Okay, so this is where the hang-up comes in. The hang-up is that they do not use their words consistently. And they never will because they're going to talk about physics and going to describe it with words that they misdefined or never defined in mathematics, then we got a problem because, you know, you can't point them against the ropes. You can't pin them against the ropes because the guy weasels around. He says, well, no, I'm talking about math. Well, then math is not the language of physics. Okay, don't bring your math language into physics, okay? Because in physics, it's got to be straightforward. You're talking about an object, you're talking about a concept. You're talking about a concept, get out, go back to math, okay? So, no, don't bring the word point, and don't bring the word singularity because they have no meaning in physics. There's no such thing, body, entity, diameter, radius, entity, I don't know, that a standalone object that is zero-dimensional, okay? That it has no size. Okay, so this fellow then defines a singularity for us. Thank God. Okay, singularity. Here's a definition in scientific terms. Okay, finally we got science here. Okay, let's see. A gravitational singularity or space-time singularity is a location. Blah 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 blah. Location. So it's a singularity is a location. Is that a physical object? Can you say that a location moves a star around? Is that what a location does? It's a standalone location, nothing there, it's just location, whatever that means. And it moves stars around as general relativity holds, that you have this singularity that affects stars far away. Not only does it move them around like in orbit around themselves, but it also withdraws some of the gas from its skin. How does it do that? I want you to explain the mechanism. How does a location do it? So yeah, if it's a location, well, you know, it's not a standalone object. And you cannot say that a location does this and a location does that interfaces with matter, especially with a star. Okay? So we got a problem with the word location used in that sense. I mean, if it's a location, so far you haven't put anything in that location. Until you do, you can't do physics. That's the point. Okay? Okay, and so he continues, he says, black hole is predominantly a collapsed star such as the mass has been compressed to a small size. This is where we have a serious problem, okay? The most accurate representation would be a black ball. Black ball, is that what a black hole is? A ball? A sphere? Perfect sphere, I guess, right? Because it's compressed slowly, it's got to be very close to perfect. And it's compact. Remember, it's completely compact. So it's like a tiny ball, right? That's what he's suggesting here. The black hole has dimensions. Oh, it does. I guess 3 of them. One of which is the Schwarzschild radius, which is, this is not the black hole, but the gravitational radius beyond which light cannot escape. So he defeats his own argument. He says, the black hole has dimensions, one of which is the Schwarzschild radius, but this is not the black hole. And so he's going to teach me a little bit, so thank God, because I'm going to learn something today. He says, to help Bill understand the black hole, we have the following pictorial representation. Oh, I'm so glad he did this, you know, because otherwise I'd remain in the dark, you know. And so he points to this loony here, this fellow. His name is Derek Muller, and he just spreads a lot of garbage around from quantum mechanics and relativity without analyzing it critically. He just spits out the party line. That's all he does. He just recites. And so this gullible numbskull, right? And what does he do? He puts a black ball there. You can see the black ball inside the black circle. And then you have the white ring, which is the matter floating around the black hole, supposedly. So the extent of that black circle is the extent of the sphere of influence of the black ball, which apparently, right, or supposedly has a lot of mass concentrated in it, okay? So they're saying it not only has mass, it's got matter because that black ball has matter, obviously. That's what they're suggesting. So it's got matter, just compressed matter. It weighs a lot, it has a lot of mass, and because of that, it has a sphere of influence that extends all the way to where the white circle starts on the inside, right? And so what happens? Is that what a black hole is? Is that what everybody out there in the world, especially in the world of math, understands by a black hole? So we have a star, right? Let's keep in mind here what the context is. We have a star, bigger than the sun. We don't care how big it is, it's just big. And it's going to compress little by little, little by little, little by little. You know, it's going to compress all the matter, all the hydrogen atoms, all the helium atoms, all the iron, everything it's made throughout its lifetime, right? It's going to compress it. And it's not going to go to zero. It's going to go and stop, for whatever reasons, at the black ball. And we don't care about the size of the black ball because so far we have something that's three-dimensional. It could be this little, could be this big, could be the size of a basketball. We don't care. The point is they're saying it doesn't collapse to zero. Okay, this is what this guy is saying. This is both him and the guy that he referenced. Okay, that's what they're saying. Okay, let's bring some evidence. Let's bring proof. Okay, and here we have the first one. Okay. And this is from a PhD teaching at the University of Toronto, and he says the following, okay? If the mass of the star is greater than about 3 solar masses, 3 times the sun, right? It goes through the neutron stage and keeps collapsing. In this case, the gravitational attraction is so intense, the neutrons are literally crushed out of existence. Out of existence. We call the object a black hole. I characterized a black hole as an object whose gravitational pressure is so intense that the matter of the object is crushed out of existence. Now, I don't know what you understand by out of existence. It doesn't seem like there's nothing there anymore. It's like, you know, we don't have length, width, and height anymore. He crushed it out of existence. I mean, that's what I understand. I don't know if you understand something different. Okay, just in case, let's keep going. Let's find out. Here's another fellow. Okay, and he said he's also a teacher, a professor at the University of Maryland. A black hole is a region. A region? What do you mean a region? I thought it was a ball. Is a region the same thing as a ball? I mean, region is a concept, but black ball is a standalone object. Okay? These people don't seem to tell the difference. For them, it's the same thing. A region is the same thing. In fact, JFG told me a region is a physical object, as far as he was concerned. So we got a problem because region is always of something else. Region is a region of your hand, like the palm is a region of your hand, right? Region is always of something else. In this case, region of so-called space, which they treat as a physical object. So they say, look, you got this body out there called space, and we're going to take a region of it, and that's going to be a black ball. Is that a fair assessment? Okay, so that's the context here. It's got nothing to do with physics. It's got to do with a lot of mathematics, okay? Region of space in which the matter is so compact that nothing can escape from it, not even light. The surface of a black hole inside of which nothing can escape is called an event horizon. So it's got a surface, right? Okay, so we're talking about a surface. Then he says the matter that forms a black hole is crushed out of existence. So what is the surface of if the matter is crushed out of existence? And just in case he makes sure you understood, just as the Cheshire cat disappeared and left only its smile behind, okay, smile is a physical object, a black hole represents matter that leaves only its gravity behind. Gravity is a concept. So if the star collapsed to the point where only left its gravity behind, there is nothing there. All we have is a concept. All we have is love. We have information. I don't know. We have a lot of concepts. What we don't have is a ball. We don't have a black ball, a three-dimensional ball. Okay? And so here I put it, this is a black hole. That's what it looks like, exactly like that. I hope you see it. Okay? Region of influence, event horizon surrounding a zero-dimensional, zero size, zero volume, nothing. Singularity. Okay? So that's what a black hole is. A nothing that the mathematicians use to explain why stars revolve around nothing. and they asked the astronomer, because those are the theoretical physicists, right? So-called physicists. And what they do is they tell the astronomers, go look for it. Go look for nothing. Okay? What does nothing look like? Well, go find it, I'll tell you. Okay, here we have another one. Okay, and this one says it's not the size of, again, this guy's a PhD, okay? I only got PhDs because I want to make sure we have the proper authority behind this, okay? Because they're going to say, well, you got this from who knows who. No, these guys are PhDs in so-called physics, okay? And they're teachers at universities, okay? So I'm not talking about just bozos that make $2 an hour, okay, here, okay? It's not the size of a pinhead, but actually has zero size, has zero size. Now, zero size, how many dimensions does that have? Does that have 3 dimensions, length, width, and height? Okay. A true mathematical point. What's a point? A zero-dimensional location. Nothing. That's what a zero size true point, mathematical point is. Okay. Matter collapses literally to a point, okay? Not a pinhead size or any size, but a literal point. 0 wide, 0 high, 0 deep. Now, I don't know if you understand. Maybe I'm wrong. I don't know. Maybe I'm misreading all these people. These are all PhDs. They're telling you it's got no width, no height, no depth. No, in other words, meaning no length. Okay, it's got no dimensions, and it's zero size. I don't know. And the other guys tell you all matter is crushed out of existence. So we have a surface, which is the event horizon. It's a surface of what? What is it enclosing? What is it imprison? You know, what is it constraining? Okay, we cannot imagine such a thing. No kidding. No, I can't visualize nothing. I can visualize, you know, a dog, a cat, a rock, a house. I cannot visualize nothing, absolutely nothing, because there's nothing to visualize. You have no shape to visualize. Okay? And he says, we cannot imagine such a thing, but physics says that it is what happens. Well, not physics, mathematical physics, okay? And that is a black hole. Matter that is so dense it is no longer matter in any real sense. I hope I'm reading all this right, okay? I'm getting this from PhDs here, right, in physics. But some kind of singularity or anomaly in space, okay? Now you tell me if I'm putting words in their mouth and I'm misreading something, please tell me. I want to know if I'm making a mistake. I really do, you know, but this is how I interpret this. No dimensions, crushed out of it, all matter crushed out of existence, only mass, only gravity, which is nothing. These are two concepts. So they're saying there's pull of gravity, but there's nothing pulling. It's like, you know, you're pulling on a donkey, but there's no one pulling on the rope that's pulling on the donkey. It's just a rope pulling on the donkey. It's not even a rope because there's nothing there. So it's you're pulling on a donkey without anything. Okay. And here, just in case, I mean, more authority. How much more authority do you want than good old Mr. Stephen Hawking? Died a couple years ago. Well, this is what he said. I mentioned this in the past, but I thought I'd put it in today for padding. We need all the authority we can get here, right, to make sure. Chandrasekhar calculated that Chandrasekhar was an Indian guy that came from India to England. He studied and worked there for a while, and he came up with a notion of black hole, or he expanded upon it. Okay, he said there are real black holes. Okay, I'll get to that in a minute. Chandrasekhar calculated that a cold star of more than about 1.5 times the mass of the sun would not be able to support itself against its own gravity. Okay, Chandrasekhar limit, that's what it's called. It's a limit, as this fellow pointed out, related to mass. No problem there. We don't care because mass has nothing to do with physics. Physics, we deal with structure, with architecture. We deal first and foremost with objects. So if there's no object, we don't care what the mass is, okay, because it's not applicable. Okay. Anyways, Eddington refused to believe Chandrasekhar's result. What was it that Eddington had a problem with? And by the way, he had it for the rest of his life. Okay, he died not accepting Chandrasekhar's insinuation that there is such a thing as a black hole. Okay, Eddington thought it was simply not possible that a star could collapse to a point. What is a point? A location. What is a location? A zero-dimensional nothing. It's a concept where you're supposed to put something in order for it to be a location. Otherwise, it's not a location. Okay, you got to put something in that location. Einstein himself. He said, thought it was simply not possible a star could collapse to a point, okay? Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. We're talking about zero size, location, no dimensions. What part does this fellow not understand? Okay? So no, we're not talking about a ball, we're talking about a nothing. Okay? It's known as nothing, not a ball. Okay? A ball is not the same thing as nothing. Okay, let's make sure we understand that. Ball has shape. Nothing has no shape. Okay. When he was awarded Nobel Prize in 1983, it was for his early work on the limiting mass of cold stars. Chandrasekhar had shown that the exclusion principle could not halt the collapse of a star more massive than the Chandrasekhar limit. Okay. Now, how much more authority do you need than that? Stephen Hawking, he's on my side. He says, look, we have this zero-dimensional nothing out there called a black hole. He's saying it's not a ball, okay? And it's not a black ball. It's those people who misrepresent because they have mental problems and they say, no, it's a ball. No, it's not a ball. All these people are telling you it's a zero-dimensional nothing, no structure, matter crushed out of existence, no dimensions, no size, no nothing. Okay, so don't tell me it's a ball. I want to make sure we destroy this notion of a ball, okay, for anyone who brings it up here, okay, in this forum at least. Okay, and here's Chandrasekhar himself, the good man. What did he say? Well, this is from his paper, 1931 paper, in which gave him eventually his Nobel Prize. And you can see the R there, R sub 1, that's the radius. And he says it goes to 0, while density, the row on the right-hand side of that, goes to infinity. And he repeats that again later on. Radius is equal to 0, and rho, the density, goes to infinity. So here we have all kinds of authority behind this. Okay, it's not that I'm inventing this stuff. I'm putting words in people's mouths, especially into the mathematicians' mouths. These are them themselves talking. Okay, you don't like it because it destroys your religion. I'm sorry, but this is your own gurus. Those who believe in black holes, this is your own gurus talking. They're saying there's no such thing as a black hole. Thing meaning that which has shape. Okay? This is not a three-dimensional ball, it's a zero-dimensional singularity, which is a zero-dimensional nothing. And just in case, after Chandrasekhar came out, here we have a paper from this fellow, okay? And he's also Indian. He says, working at Cambridge, he came after Chandrasekhar. He is still alive today, obviously. On solving the equation with a particular value, rho sub c of central density, you will get a model of a star with mass m and radius r. Okay, we understand so far? Mass m, radius r. Plot r as a function of m and show that r falls to 0. 0, r meaning radius, right? As a function of m, right, mass, and show that r falls to 0 when m is equal to the Chandrasekhar mass. R goes to 0. Okay? If you can do these, then you have repeated the calculation for which Chandrasekhar won the Nobel Prize. Okay, what part does this fellow not understand? A black hole has 0 radius, the singularity, okay? It's a pinpoint nothing that's got infinite density because it's got all this infinite mass in no volume. That's why it's infinite. So one goes to infinity, the lying down 8, and the other guy goes to 0. What part does he not understand? He thinks it's a black ball, and all these people think it's a black ball. It's not only him. JFG also thought it was a black ball. Everybody has this idea that it's a black ball. So the mathematicians are getting away with murder when they say, oh, it's a black ball, and everybody says, oh, okay, I understand that. Because if they said, look, it's 0 dimensional, there's nothing there, but it's got infinite mass, well, a lot of people would start questioning that. But if they say it's a black ball, then everybody says, oh, okay, that sounds reasonable. It's just compressed matter, and it weighs a lot. That's the only notion people have of a black hole. That's about as complicated as a black hole gets. Here we have another one. I'm going to insist on all kinds of authority here because that's what people need. People need authority to tell them that there's no such thing as a black hole. Now, this one is interesting because this came after Chandrasekhar, and this group of people proved again that yes, indeed, a black hole is 0 dimensional. No size, no dimensions, no radius, no diameter, no nothing. Okay? And here it is. This is the article. Okay? And the article went like this. It says, a point of infinite density and space-time curvature known as a singularity, okay? And usually found at the center of a black hole, okay? Can also exist in a naked form without its black hole. What is a naked singularity? I'll get to that in a minute, but just for your information, for those of you who don't know what a naked singularity is, it means a singularity that does not have its event horizon. There is no sphere of influence surrounding a naked singularity. All it is just a singularity. And what was a singularity? It was a location. A location that has what in it? It has mass, gravity, or who knows what, maybe angels. But for sure it doesn't have any structure, no architecture, no body in that location. So it's the center of mass of nothing. Okay, let's make sure we understand that. Okay, it says Lenner, together with Franz Pretorius of Princeton University, showed that at the point where a smaller black hole pinches off from the stream, the black hole's radius is 0. Now, what part of 0 don't you understand? Which means that its density is infinite. Again, the only way it can be infinite if you have 0 volume. I hope this is clear. I don't know. People who know a little bit of math, I'm sure, will understand this. Okay? In other words, it is a naked singularity. Kip Thorne was in the audience and said the study was beautiful work. And Kip Thorne, I mean, he's a Nobel Prize winner as well. So, I mean, Jesus, oh, you got a lot of authority here saying, look, you don't have nothing there, okay? And here's the paper they were referring to, okay, from Lenner and Pretorius. And this is what they say in their paper, okay? It says, the simulation results imply that the string segments will reach 0 radius in finite asymptotic time, whence the classical spacetime terminates in a naked singularity. That's what they say in their paper. So what the hell is a naked singularity? Okay, let's put it up here so we are all on the same page, okay? And here they say the following. This is out of the wiki, okay? In general relativity, a naked singularity is a hypothetical gravitational singularity. Location, center of mass, whatever, without an event horizon. I like the next statement that I read there, or the couple paragraphs down. Says, from concepts drawn from rotating black holes, it is shown that a singularity spinning rapidly, blah, 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 blah. So here we have a naked singularity, which is a location without body in it, without any event horizon, sphere of influence, and nothing is spinning. So yeah, you get all this word wizardry from the mathematicians because they can get away with anything. I mean, you know, when I was working as an engineer at AMD, I had to produce results. You don't produce results. The engineering manager, you'll hear his voice, the voice of wisdom. But these guys can say anything they want. They can talk about angels. People will just believe them on the basis of authority. They say, well, he's a PhD. He studied 10 years. He must know. Somebody must. Right? Okay, so here's another comment. That's the final comment this guy made. I love it because it was a pretty good ending. It says, there's still a lot we don't know about black holes, and most of the fun of science is in the discovery. What a mental case. I mean, no, science is not about discovery. Science is about explaining, okay? Anybody can go and discover. Discover what? Discover God? I mean, what are you going to discover? Angels? I mean, you know, a lot of people find these discoveries. You know, they go out there and they say, oh, yeah, I discovered God. Okay, so great. You know, so no, science is not a process. Science is explaining, okay? And so, and as far as black holes, we know everything there is to know about a black hole. There is nothing more you need to know about a stupid black hole. Black hole is simply a star that collapsed to nothing. That's what they're saying. And that all the gravity or the mass remained behind, but the elephant was gone. Okay, there's no structure. That's it. What more do you need to know about a black hole? What is it that is so, you know, mind-boggling about a black hole? It's very clear. It just says that all the mass, whatever mass is, right, because that's another issue, but all the mass of a sun, of a star, collapsed to nothing. And what you have is a location called a region, known as a singularity, center of mass, of what? Of nothing. It's got this region of influence that moves stars around far away. Who knows by what mechanism? Because that's the other issue. How does, you know, a singularity, because even if we concede mass, infinite mass, whatever you want, I don't care. Okay, so you got mass, okay, infinite mass. And if you want a black ball, I'll give you the black ball too. The question is now, how does that black ball mass, whatever you want to call it, how does it move a star far away? That's what I want to know. Okay, and what they say, well, it weighs down the canvas of space-time. And the other guy falls in. That's a two-dimensional vision of so-called four-dimensional space-time. And I've discussed that at nauseum in the past. So yeah, it's totally retarded, mentally retarded for people who have mental problems, who have lost touch with reality. They're no longer in touch. They don't no longer have their feet on the ground. Okay, that's the problem. Okay, here are other issues. Another issue was brought up. Another comment. Oh, no, sorry. This is, again, the picture that they took of a zero-dimensional black hole, okay? And you say, well, if it's zero-dimensional, what I'm staring at is at least 2 dimensions there, right? At least. And you have to think of that as three-dimensional, as a three-dimensional object. Now, the first issue, this picture was taken by several people over several days. So what you're staring at is a composite picture. That's the first thing that is not always clear to people. They think that these guys just went through the telescope and took a snapshot. That's what most people believe because they don't know how this thing works. But no, this was taken through a composite taken from several laboratories. It was punched into a computer and they created this image, okay? So this is not a snapshot. That's the first thing we need to clarify. The second one is, well, what are we staring at? Is that dark thing in the center a black hole? Because that's what people think. They say, oh, okay, I see the black hole. It's that little ball, black ball in the center. No, that's not the black ball. No, that's not the black hole, okay? Because a black hole is zero-dimensional, okay, remember. And so what they're saying, this is the matter falling into this zero-dimensional, you know, black hole. And the question is, how does matter penetrate, you know, real matter? How does it penetrate a zero-dimensional nothing? How do you do that? I mean, how do you sneak through it? Do you put Vaseline around the matter so that it can slip in there? I mean, I don't know. Please explain the mechanism. How does a three-dimensional atom go through a zero-dimensional nothing location? Okay, so this is the issue. And here is the mechanism that I was talking about. I mean, here we have a turtle, and it's going around mass. Okay, so you want to put a ball there, put a ball, I don't care. How does the mass affect a turtle? Why does it, you know, what's the mechanism? How is the turtle affected by mass? That's what I want to understand. Please illustrate the mechanism, meaning please fill in the blanks, put an object there so that we can see, you know, how the turtle is tied to this word called mass, whatever mass is. And that takes us to the word mass, obviously. And, you know, I've covered that in the past, but just to close the argument here, you have a circular argument of mathematical physics. Say a black hole is made of mass. It's not made of architecture. It doesn't have any object in there. It doesn't have any matter because it's been crushed out of existence. There's no length, width, or height, no dimensions, no size, no radius. Okay, so it's just got mass, infinite mass. Okay, we'll concede. So it's got infinite mass. It turns out that, you know, mass is the quantity of matter. That's what most people understand by mass. And then they tell you that all matter is crushed out of existence, that there's nothing there. So we got a circular argument there because we have black hole is made of mass. That's all it has, okay? At least a non-rotating black hole, one that has no charge, you know, etc., okay? But all it has is mass. For sure, all black holes have mass. And here we have, you know, mass is the quantity of matter, the notion most people have of mass. And here it says that all matter is crushed out of existence. So even if mass were the quantity of matter, we have we have no mass. Because you crushed all matter out of existence. You got rid of the elephant, now you have no mass. You only have 6 tons. What does that mean? You know, what sense can that mean? And then, you know, just to top it off, we have always the good gurus of mathematics. I'll put it side by side here. And that's Edwin Taylor and John Wheeler. Those who don't know John Wheeler are not into mathematical physics at all because he's a very famous guy, died already. And he says, nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count number of atoms or by any other counting method, try to evaluate amount of matter, that number would not equal mass. So this stuff that they teach you in high school, that mass is the quantity of matter, that's BS. Okay, mass is not the quantity of matter. In fact, the Wikipedia mentions that there are 7 different types of notions, 7 different notions of mass. And when you go to the physics fact run by the University of Riverside, Mr. John Baez, you know, he tells you, his group tells you there that you have at least 2. One is inertial mass, and the other one is, or rest mass, and you have the other one which is relativistic mass. What is relativistic mass? Well, it means that it depends on speed. So how does the quantity of matter depend on speed? So yeah, we got a problem because then that relativistic mass has nothing to do with the mass that good old Newton dealt with, you know, 400 years ago. So yeah, mass has suffered a transformation, a tremendous transformation. Okay, so here let's get to the other comment now. Yeah, I will. Well, let me get it in here. Okay, this is one fellow who says, so distance does not apply to vacuum and nothing? Well, I don't know what he's actually talking about. All I can do is answer his question the way he phrased it. And so here's my reply to that. Let me get that up here. And no, there is no separation between vacuum and nothing. So, you know, I'm not sure what he meant by that, but I'm just answering his question. If he's saying that does distance refer to vacuum and nothing? No, there is no distance between vacuum and nothing. And here, just in case, just to close today, I put this little thingy here, this little graph, or this little chart, says distance is what lies between lengths. Okay, that's what I would say. Distance is the separation between 2 objects. You have to have an object. You can't do it between vacuum and nothing. Okay, and so you know, again, what we have to do is clarify the question, because otherwise it makes no sense. You know, you can't just put a quick notion in there and say, well, you know, doesn't distance apply to vacuum and nothing? Well, I don't know. Vacuum, nothing are synonyms, and there is no distance between them because they're the same thing, and it means there's nothing, absolutely nothing in that space, because space is the same thing as vacuum and nothing. Okay, with that, I hope to see you on Wednesday, and what I'm going to try to do is get back to the existence of time. Does time exist? We'll deal with that on Wednesday. We'll see you then. Bye-bye.